In this video, we're going to take a look at the exponent rules. I'm going to help you recognize them, understand them, and use them in some basic examples. Here's a look at all of them at once. And we're going to go through each of these one at a time and look at the structure of each and a basic example. So here's the first rule that most people seem to know, is that when you multiply like bases, what you can do is add exponents. So this is the idea of addition. So you're going to be looking for x to a power times x to a power, or it could be any variable. They just have to be the same. And then what you're just going to do is you're going to add those two. So an example might be something like if you see x squared times x to the third, you're just going to add the 2 plus 3, so it's just x to the fifth. I also want to point out that it's important to recognize how to work in these in reverse. Now, it doesn't have to just be x. You can do this with numbers as well. So if you have 4 squared times 4 to the third, that's going to be 4 to the 2 plus 3, so it's 4 to the fifth power. And the reason for this, as you see, if x squared means x times x, x to the third, you'd be multiplying 3 x's, so basically you have 5 x's. Our second rule is known as a power to a power, and this is where you multiply the exponents. So if you see the structure of something to a power raised to another power, what you can do is simply multiply those two powers. An example here would be if you had x squared and it was raised to the third power, what you're going to do is x to the 2 times 3. So we end up with x to the sixth. And again, we can look at it with numbers. So if we had 4 squared and that was raised to the third power, we just do 4 to the 2 times 3, so it's just 4 to the sixth. Sometimes people tend to confuse these two rules, so take a minute to really look at what you're doing here and know when you multiply versus when you add. And the reason for this is same type of reasoning. If you had, let's say, 4 squared and you raise it to the third, that means you have it 3 times. So that means you're going to have 2 3 times, so 2 times 3 is 6. Our next rule is very much like the distributive property for exponents. So we're going to keep the idea of distributing. So when you have variables grouped together or anything grouped together in parentheses raised to a power, what you're going to do is distribute that power to each one. So you'd have x to that power times y to that power. An example might be if you have xy, let's say, to the third, that means you just get x to the third and you have times y to the third. And it also works if we can get a little more involved here. If we have something like 2xy, let's say y is squared and it's raised to the third. So you would have the 2 would be raised to the third power, the x is raised to the third power, and our last piece here, this y squared, it's y squared is raised to the third power. So this ends up being, let's say, 8 x to the third, and here we have the power to a power, so we're going to multiply and have y to the sixth. And here's a rule that comes up quite often. If you have anything raised to the 0 power, it's equal to 1. This seems counterintuitive for many people, but if you take a look at a table of values, if you're looking at an exponent, let's say we're looking at y equals 2 to the x. Most people feel pretty comfortable if they plug in 1, 2 to the first power is 2. If you plug in 2, 2 to the second power is 4. If you plug in 3, 2 to the third power is 8. Now, if we look at our pattern here, we're going backwards. I'm dividing by 2 following this pattern. So when I go to 0, if I divide by 2, I get 1. So this tells me that if I have 2 to the 0 power, it must be equal to the 1. Anything grouped to the 0 power is equal to 1. So even if I have a whole bunch of stuff, let's say 3x squared y, and it's raised to the 0 power, I basically have this whole thing in a group raised to the 0 power, so it's equal to 1. And there are other ways to look at this. This is just one view. The next rule is for division. So you saw earlier when you have multiplication of like exponents, you add. Here we have division of like exponents, so we're going to subtract. So it should make some common sense to you. And so when you see this, you're going to have x to the, whatever's the upper one, and you're going to subtract the lower one. And an example might be if we have x to the fifth up here, and it's over x to the squared to the second, that would be x to the 5 minus 2, which is x to the third. And the reason for this, you might look at it this way. If x to the fifth, I would have 5 x's multiplied. And down here, I'd have 2 x's multiplied, and you can cancel those out and you're left with 3, which is why it's subtraction. And again, it works with numbers as well. So if I was to squeeze in a little example here, if we have 2 to the 7th, and that's over 2 to the 3rd, we just do 2 to the 7 minus 3, which is 4. Our next rule involves the idea of negative exponents. And when you raise something to a negative exponent, really what you're looking at is the positive value in the denominator, or we can say the reciprocal. So the reciprocal is when you flip a fraction. Reciprocal. There we go. So if you see x to the negative anything, you can just immediately rewrite it as 1 over x to that positive value. And if you want a quick reason for this, let's say you have x to the second over x to the third. Earlier you learned that means you can subtract the exponents. So that would be x to the 2 minus 3, which is negative 1. And also, if you look at it this way, you'd have x times x over x 3 times multiplied. They cancel out, and it leaves you with 1 over x. So x to the negative 1 is equal to 1 over x. So if we have something like x to the negative 3, that's simply going to be 1 over x to the third power. And it works with numbers too. So you'll see some examples where you might have 4 to the negative 2. So that would be 4 to the positive 2 in the denominator, which is simply 1/16. So very important here, negative exponents do not mean negative numbers. They really mean division is what it comes down to. And you can relate this to what you may know about scientific notation. This next rule is a little interesting because it's working with x and y grouped together in parentheses. And if it's to a negative exponent, really what we're doing, notice we're just flipping the fraction. In other words, we're finding the reciprocal and it's raised to the power, positive power. So if you have x over y or any fraction raised to a negative exponent, you can switch the numerator and the denominator, and it's now raised to a positive exponent. An example might be, let's take something as simple as x over, we'll say y squared, and we'll say that's to the negative third. Well, that's simply going to be y squared over x, and now it's all raised to the positive third. Now we're going to take this idea and let's look at it down here for this next rule. So it's the idea that something is grouped together, so it's still the idea of distributing, just like you saw earlier with multiplication. So if you see x over y to some power, or any numerator or denominator, that entire numerator gets raised to the power, and the entire denominator gets raised to the power. An example could be something like, let's just look at the idea of 3 over x squared. And if we raise that to the 4th power, that means 3 is going to be raised to the 4th power, and x squared is raised to the 4th power. And you saw earlier, power to a power, you're going to multiply, so we have 3 to the 4th over x to the 8th. And if we want, we can rename 3 to the 4th as 3 times 3 times 3 times 3, which is 81 over x to the 8th. Now our final two rules, kind of a bonus rule I like to think of. So it says x to the 1 over a number is equal to the nth root. So this is called an index, but this really means the nth root. And there's some basic problems I want you to look at. So if you have x to the 1 over anything, it's that root over x. Now the most basic example is x to the 1/2. That actually means x to the second root. And it's understood when you have a square root that it is the second root. So x to the 1/2 means the square root. Similarly, if you have x to the 1/3, that actually means the third root of x. So if you have something written down, let's say it says 25 to the 1/2 power, that just means the square root of 25. I like to think of it as this 2 is the root, so we're doing 2 in the bottom. It's the root of 25. So we're having the square root of 25, which is simply 5. This next rule puts them both together. It has a power and a root. So notice up top we have the power, and in our denominator we have the root. So we still have that n here for the nth root, and then we can raise it to the nth power. So if I have something like this, we would just say whatever is in the denominator is going to be our root. Whatever's in the x or in this spot goes under the radical, and then whatever the power is, we can raise it to. And this can be written two different ways, so we'll take a look at that in a minute. So if you have x to the 2/3 power. That simply means the third root of x, that entire thing squared. And yes, that is the same as saying the third root of x squared, so it doesn't matter where you put that. An example using some numbers might be something like 8 to the 2/3. This means you're going to take the third root of 8 and raise it to the second power. And hopefully you know that the third root of 8 just means what number multiplied by itself 3 times is 8, and that is 2. And then that will be raised to the second power, and that equals 4. That's a basic look at all the examples. I hope that helps you, and we'll take a look at some more complicated examples in the next video.